In this video, I'm going over the practice and review that we're going over in class today for quiz 2. With these first few questions, we're again focusing on simplifying the radicals, whether it's a real or imaginary. So notice here with the first one, this is the square root of negative 64, which of course we can break that apart to the square root of 64 times square root of negative 1, which, if you recall, the square root, the square root of negative 1 is I. So we have I here for our final answer. Then the square root of 64 is 8, so 8I. But then notice, right, we have to multiply by negative 3 here. So I'm going to now multiply by negative 3. Negative 3 times 8 is negative 24. So negative 24I. The number 2. Now notice here on the outside we have that negative. So that's going to be negative 1 being multiplied to our answer here at the end. Now also notice that the square root of 704. Well, the square root of 704 is positive. So I don't need I in my answer because this is a positive value. We don't have the square root of negative 1. So I'm going to mark off A and C because they involve I here. Then when I break this apart, you end up with the square root of 64 times the square root of 11. And then so here, when I break that apart, the square root of 64 is 8. So 8 radical 11, but remember, right, we have to multiply that 8 by negative 1. So that's why this is negative 8 times the square root of 11, which is D. Then the last one here, notice how we are breaking apart the square root of negative 72. Also notice we are multiplying by this fraction here 1/2. So I'm going to write that on the side here to save for the end. So we're going to multiply by 1/2. Now notice that is a negative 72 that we're finding the square root of. So we do need that value to be positive. So we're going to take out the square root of negative 1, which again now we have I, our imaginary unit. So when we break this apart, if I were to think of perfect square factors, I could use 9 and 8 or the square root of 36 times the square root of 2, radical 2. Now I've got radical 36, so square root of 36 is 6, right? So 6 radical 2. Then I do need to bring down, so notice how we need I in our final answer, and we are multiplying by 1/2. So as we simplify, 1/2 times 6, or half of 6 is 3, so 3I radical 2. With the next question, notice how it's asking for how many solutions. So remember, quadratics could have 2 real solutions, 1 real solution, or no real solution, right? Because remember, that's the same as saying 2 imaginary. And to figure out how many solutions, we would use the discriminant. We would calculate the discriminant, which is just b squared minus 4 times a times c. Then we would identify what is your A, our B, and our C, and substitute. So B squared, negative 12 squared, minus 4 times A times C, which is negative 10. Now we can simplify. So here, negative 12 squared is positive 144. Then here you have negative 4 times 4, negative 16 times negative 10. Then notice now multiplying two negatives making a positive 160. So this is 144 here plus 160, which gives us the discriminant of 304. Notice how because this is positive, right, greater than 0, you have 2 real solutions. So again, because this is positive, greater than 0, you have 2 real solutions. With these next couple of questions, we're going to solve here. So we're solving for x. Notice using test-taking strategies with the answer choices, notice how they're in this irrational form. So that means we are going to use the quadratic formula where x is equal to negative b plus or minus the square root of our discriminant b squared minus 4ac all over 2a. I'll break it apart and just first focus on the discriminant, what's going to go under our radical. So again here, b squared minus 4 times a times c, where then we identify our a, our b, and our c. So here b squared, 7 squared, minus 4 times a, which is just understood to be 1, times c, which is 3. Then 7 squared is 49. 49 minus 4 times 1 times 3 is 12, giving you a discriminant of 37. So I'm going to mark off C and D because I need a discriminant of 37, not 61. Now I'm going to continue. So here we've got x is equal to negative b, which is 7, plus or minus the radical 37 over 2 times a, or 2 times 1. So notice how here I do need in my numerator negative 7 plus or minus radical 37 over 2. So that's why the answer is B. Then question number 6. So again, I'm going to focus first on the discriminant. So b squared minus 4 times a times c. So identify your a, b, and c. B squared is negative 5 squared minus 4 times a times c. Now I go through and simplify. So here I've got positive 25, negative 5 squared, minus 4 times 2 times 7, which is going to give you 56. When I subtract, I do get negative 31. Now, remember, if I have a negative discriminant less than 0, that means we're going to have two imaginary solutions, right? We're going to have no real when we have a negative discriminant. That means I need I in my final answer to represent my imaginary. So I'm going to mark off B and D because they don't have I or the imaginary value. Now I'm going to continue to see what our final answer is going to be here. So again, x is equal to negative b, which is negative 5, plus or minus the square root of negative 31 all over 2 times a, 2 times 2. Now notice here, we do have two negatives together. Two negatives make a positive. So positive 5 plus or minus. Now, square root of negative 31 is same as I times that radical 31 from the square root of negative 1 over 2 times 2, which is 4. So here, that's why the answer is A. The next section now is our spiral review. So notice how we are factoring completely. First step is always, do we have a greatest common factor that we need to factor out? And in this case, we do. I can factor out that GCF of 4. So when we factor out 4, now I've got x squared plus 10x plus 25. Now I can continue with my factoring. So here, now we continue on. What two numbers multiply to get you 25, right? And add to get you 10. That would be 5 and 5. 5 times 5 is 25, and 5 plus 5 is 10. So don't forget the 4, right? Our GCF. So 4 times x plus 5 times x plus 5. Now, if we also wanted to simplify this even more, this is the same as 4 times x plus 5 because it's being multiplied to itself to the second power. Now, question number 8. Notice how we are solving. So, but in order to solve, remember our quadratics need to equal 0, but right now it's equal to 4. Make sure to subtract 4. Are there any like terms to subtract 4 from? No, so we're just going to bring everything down. 5x squared plus 8x minus 4 is now equal to 0. Now, do we have a GCF? No, but because A is greater than 1, it's 5, we're going to go ahead and start our bottoms up. So 5 times -4, our A times C. Now I've got x squared plus 8x minus 20 is equal to 0. Now we can continue our solving by factoring. What two numbers multiply to get us -20 and add to get us 8? +10 and -2. But then is our answer these two values? No, right? I'm going to mark off A and B because remember, right, with bottoms up, whatever that A value was that we multiplied to C, now you need to divide by 5. So this is x plus 2, and then bottoms up. 5x minus 2 is equal to 0. Then remember, because we are solving for x, right, this is equal to 0. This is saying that x plus 2 is equal to 0, which if I were to subtract 2, you get -2. And this is 5x minus 2 equal to 0, which again, add 2 to both sides. 5x is equal to 2 and divide by 5, getting you that 2/5. That's why, again, here the answer is D. And again, just that pattern on changing those signs, but that's because here solving for x setting equal to 0. So number 9, notice how we are solving and we're already, our quadratic is equal to 0 and in standard form. Our A is equal to 1. There is no GCF, so we're going to go straight to our pattern of what values multiply to get you -12 and add to get you -4. Now use test-taking strategies and notice how our answer choices show 6 and 2. So we need to now figure out, using 6 and 2, what's going to multiply to get you a negative, right? So I know I need a plus and a minus, but add to get us -4. So in this case, -6 and +2. That's going to add to get you -4. But again, because we're solving and this is equal to 0, that's the same as saying x plus 2 is equal to 0 and x minus 6 is equal to 0. So when you solve, you would subtract 2. So x is equal to -2. Here you would add 6 to both sides. So x is also equal to 6. That's why the answer is A. With question number 10. Now I'm noticing we just have 2x squared, but we have no x term, just our constant. So if there's no x value, I'm going to go ahead and solve this using the square root method. So I'm just going to treat it like a two-step, where here I'm going to subtract 35 because I'm solving for x. So subtract 35. Now I have 2x squared is equal to -22. Now I'm still solving for x, but it's being multiplied by 2 here, so I now need to divide by 2. And x squared is now equal to -11. Now we have x squared here by itself. Take the square root. Notice you're taking the square root of a negative value. So this square root of -11 is the same as radical 11 times radical of -1, which again here we remember here is I. Well, there is no radical 11 and you can simplify it. So the final answer is I radical 11 plus or minus. Question number 11. Again, now we are solving. I do have my trinomial. It's in standard form and equal to 0. So again, first step, do we have a GCF, a common factor? Yes. I can divide all of my values and take out that 2, factor out 2. So really we've got 2 times x squared minus 7x plus 10 is equal to 0. Now we can continue our factoring. I'm going to bring down my 2, right? So now we've got what values multiply to get us 5 and add to get us -7. Well, here if I'm multiplying to get a positive, but adding to get a negative. I know both signs need to be negative, so to multiply to get a positive. And in this case, -5 and -2. They would also add to get you -7. But because we're not done, right, we are solving. So this is 2 is equal to 0, but will 2 ever equal 0? No. So that's why our 2 here just cancels out. 2 is not equal to 0. But here we have x minus 5 is equal to 0 and x minus 2 is equal to 0. So here when I add 5, now I have x is equal to positive 5. When I add 2 to both sides, I have x is equal to positive 2. So that's why the answer here is B. We didn't do bottoms up. I don't need to divide. It's just we used our GCF here. So then we can solve and equal to 0. So now with number 12, we are going to factor completely. Notice how it's not a trinomial, right? Like here we have 3 terms. Here we only have 2 terms. Notice how b is equal to 0. There's no x term. So if I have a difference of 2 perfect squares, because the square root of 9x squared is 3x. The square root of 64 is 8. So we can write our difference of squares factored out here, that special case. This is 3x plus 8. But then remember, right, to get that negative value, we have 3x minus 8. With our next problem, we are again solving. I notice that I have x squared and only constant. So again, b is 0. We have no x term here. So again, I'm going to solve this as if it's using the square root method. So I'm going to solve for x. I'm going to add 40 to both sides of my equation. So now I've got here 3x squared is equal to 81. Now still solving for x, but it's being multiplied by 3. So now I'm going to divide by 3. X squared is now equal to 27. Now we have x squared. Take the square root. Notice how we can simplify the square root of 27. So let me write it here, because this simplifies to the factors of the radical 9 times radical 3. The square root of 9 is 3. So 3 radical 3. So x is equal to positive or negative 3 radical 3. Then question number 14. We are factoring. So notice how we're not solving, we're just factoring. There's no equal. So here, again, I have my trinomial. I have no GCF because A is 1. So I'm going to go straight to identifying what values. Multiply to get me positive 26, but add to get you negative 15. Again, you're multiplying to get a positive, right? But adding to get a negative. That means both signs, again, need to be negative. Then looking at my answer choices, notice how we're just using factors of 13 and 2. So 13 times 2, negative 13 times negative 2, positive 26, but add them and you do get negative 15. So that's why the answer is C. And then last question here, again, we are factoring. Sorry, we are factoring, not solving. There's no equals. So here, is there a GCF that we need to factor out? No, but A is not just 1 now, A is greater than 1. So we do need to start bottoms up where we multiply our A times C. So this becomes x squared plus 3x plus 2. Now we can factor using our pattern here, right? What numbers multiply to get you 2 and add to get you 3. 2 and 1. 2 times 1 is 2. 3 plus 1 is 3. But is this our final answer? No, right? Because remember, with bottoms up, what that A value is that you multiply by, make sure now to divide. So this becomes x plus 1 times, remember, right? Bottoms up, 2x plus 1. Then, of course, and I haven't shown this in a while, but how can you check your work? How do I know that I got the right answer? You can set this up by multiplying, right? Use the box method. So here I've got x and positive 1 and 2x and positive 1. Now I can solve 2x times x, 2x squared. 2x times 1, 2x. 1 times x is just 1x or x. 1 times 1 is 1. Then notice on that diagonal here, we have like terms to combine. So I've got 2x squared plus 2x plus another x. We now have 3x's plus 1. So notice how I ended up with the same trinomial.